a particular question from the lecture notes to do with finding the gradient. So this is question 2a, and it states the following. Find grad of phi for each of the following two-dimensional scalar fields, given that the vector r, denoted with r underline, equals xi plus yj, and r, which is scalar, no i's, j's, k's, etc., is just root of x squared plus y squared. And express your answers in terms of vector r. Okay, so there's a few questions to do. I'm going to run through the first one and perhaps talk briefly about the second. So I'll go through A and then mention B and allow you to work through the others. The solutions, of course, are there in the lecture notes. So first thing we have is phi is equal to r. But r, of course, as we're told in the question, is just the square root of x squared plus y squared. So phi is just this. Or it might be easy, perhaps, in terms of the calculus we have to do, to think of it as x squared plus y squared to the power of a half. Okay, let's leave the question alone just for a minute, because the bulk of the question is doing partial differentiation. So let's look at the notation in blue and do the following. So I've created z. I'm going to say z equals x squared plus y squared to the power of a half. And the question is find delta z delta x. So let's see if we can make sense of this. This will be a chain rule question. So I'm going to let u, the innermost function, the bit in the brackets, be x squared plus y squared. And then I do partial differential with respect to x. So if I partially differentiate this, my x squared goes to 2x. My y squared, which is for the moment a constant, goes to 0. So delta u delta x is 2x. If I now go back and rewrite z, but of course use my simpler version with my substitution in place, z equals u to the half. So delta z delta u, well, the half comes down to the front, and I take 1 off the power, and I get a half u to the minus a half. The formula for chain rule says that delta z delta x will be the product of these two things here. So that's 2x, a half u to the minus a half. So the half and the 2 cancel, and u to the minus a half can be written as 1 over u to the half. So I get this. But of course u was x squared plus y squared. So u to the half is the square root of x squared plus y squared. So I have my answer in terms of delta z delta x. Now if I wanted to do the same thing with this z, but partially differentiate with respect to y, we would use exactly the same method, and I'm hopeful you can work through it and see that it'll look very similar, except we'll have y over square root of x squared plus y squared. Okay, so have a read through that, go through it again, make sure you're happy with the partial differentiation using the chain rule. Now, what do we know generally about grad of phi? Well, grad of phi is delta phi delta x times I plus delta phi delta y times j. So finding these first partial derivatives, they are just the coefficients of our I and j, plus maybe k if we have a three-dimensional vector, but in this case it's 2D. So grad of phi in our first question is just partial differential with respect to x, I, and the partial differential with respect to y, j. So this is our solution. Now if we tidy it up, we can see they share a common denominator, so we can drag that out to the front, and we're left with this line here. Now if you go back to the question, you'll see that this scalar field root x squared plus y squared is just r, and of course this particular vector, that's our vector r, or r underlined. So if we put it all together, we can see that we just have vector r over r, and that's the solution we should be looking for. So there's a few things here that make it a bit tricky. The fact you've got to do chain rule on partial differentiation, and then I think the extra complication, we have to be able to use the notation given in the question. So r underlined and r for the vector and for the scalar field. Okay, So that's that question complete. The methodology there should allow you to work through the other questions in question 2, so B and C, etc. If we have a very brief look at B, phi is ln of r, and of course we know what r is, we're told that in the question. So we're actually looking for ln of the square root of x squared plus y squared. Now clearly, to find the grad of phi, we're going to have to do partial differentials. That's what we see here in our formula for grad of phi. That's what grad requires. So you're going to have to do differentiation of this. Now this looks initially to be quite tricky because you've got your x squared plus y squared inside a square root function. That implies chain rule. And then that then is inside the log function. So it looks as if we have to do a chain rule inside a chain rule. The good news, however, is when you do the substitution of x squared plus y squared to the half, you already know the solutions for that partial differential because you've done them here for part A. So have a go at that and see if you can match the solutions that are available on the following slide.